Hi, Angie. Thank you. As usual, let's start with Zendu. So, last week we finished reviewing the design document about the management of those sidechains whose use case doesn't require the seizing functionality. And in particular, the approach that we're going to follow is the one focused on the variable epoch length. So, uh, let's say there are some sidechains where the mentioned backward transfer request is not required, where we don't bind the sidechain to answer to a request. So for these sidechains, we can relax, as we said in the previous weekly insider, we can relax the concept of seizing, and but the question was how we do it, how we implement it in an efficient way. So after having performed this analysis, we saw that the best approach to proceed with is making a variable epoch length sidechain. These will allow, for example, for a sidechain to submit a certificate maybe even with a let me say higher rate or a lower rate based even on backward transfers request happening on the sidechain side, and this is possible obviously because we don't have let's say the requirement of posting the certificate and answering to mention backward transfer request. In reality, we are even thinking, I mean, but this is not for now, it's for the future, of extending Zendu, not only for this case, but also for other cases to a variable epoch length, but it is still to be analyzed and it's not currently the focus. These changes are going to be needed for the EVM sidechain that, let me say, is using a semi-decentralized approach. And so we will be able to let's say, take the benefits of that. Okay, so going on with Zendu. While exploring the code for changes related to the non-seizing sidechain, we also found a possible area of improvement that is related to the verification of shielded transactions. I mean, and in particular regarding zk-snark that seems to spawn n threads, one of each core of the machine, to be used for parallel verification. But as of today, it uses only one of these threads. Additional checks have to be performed, but currently it seems we can introduce a possible optimization for the PHGR transaction, and this could result in an increase of performance when we sync and do re-index operation. So, I mean, PHGR transactions are let me say, deprecated right now, but for the initial blocks, let's say, I mean, the initial, for many blocks, we had a PHGR transaction, and so we can speed up a little bit that phase of syncing. Okay, switching on to the SDK. In particular, for what regards Blaze, we're bringing on the developments related to the next version of Blaze, that is 0.40. And as part of this, we have been working on multiple things, like, for example, forger transactions filtering strategy that has been changed, so sorting by fee rate instead of fee. And everything has been completed and merged. Then we, regarding the improvements related to the mempool, where the maximum size limit was added with automatic cleanup strategy per fee rate, is currently under review. And other improvements related to the login system are also under review. While, I mean, always related to Blaze, the developments concerning blocks and transactions from remote parsing improvements and DNS seeder for the SDK nodes are currently in progress. So this was all for Blaze. On the other hand, for what regards the EVM sidechain, MetaMask now works with the sidechain EVM RPC server. But on this, Victor maybe will provide a bit of more details. And stake, withdrawal request, and EOA message processor are completed. So these are quite important part of the EVM sidechain implementation. Moreover, we added the chain ID support for the transaction. So you're able to specify the chain identifier in the transaction. This is another important feature added. And for what regards the EVM execution processor, the implementation has been completed and is currently under review. And this is another, let me say, core part of the EVM sidechain, because it's the part that, let me say, allows the possibility to execute, to invoke the EVM, and so invoke a smart contract, and also invoke the specific implementation for example, staking or withdrawing. Last point regarding the EVM sidechain is that the RPC server wallet related endpoints implementation is currently in progress. Okay, last topic for today is the proving system, where during the last couple of weeks we went on with analysis on the Plonkish arithmetization and AIR, and we are deeply analyzing VM memory management alternatives. And this is obviously part of the zk EVM implementation strategy. Okay, these were the main points for today. Back to you, Angie. Thank you.